Hi everyone, in this video I'm going to be covering the transcription terminology that's used in class, and I'm going to go over a few examples as well so you can practice. I think practicing makes perfect, and it helps you really understand and reinforce those concepts. So the first thing I'm going to address is the language that we use. So in class you're going to hear the words coding strand and template strand. These are very important, but do remember that coding is also known as the non-template strand, and template strand is also known as the non-coding strand. I like to think of these words as the tops being like the original strands, like or the original names, and then the non versions being like the 2.0. You can think of it however you'd like. We'll typically say coding and template. However, if you do hear the words non-template and non-coding, that is what they mean. Again, they're synonymous with coding and template strand. Okay, so moving on to coding strand specifically. The coding strand, again, also known as the non-template, is also referred to as the sense strand. The sequence is identical to the RNA transcript that's produced, with the exception that thymine is replaced with uracil. Again, RNA does not have any T's, so it has to be replaced with U's. So the trick I like to think of is coding, which is, again, comes from a code. Same code as the RNA that will be produced. So coding starts with a C. Change also starts with a C. So again, code C, change C, and change those T's for U's. So a real world application would be like coding something on a computer. You need to copy the exact same thing or your program won't work. So again, I like to think of the phrase go code or go straight to copying the exact sequence that's given. So if you're given the coding strand, all you have to do is copy it exactly, except you need to erase the T's and replace it with U's. The coding strand is also what will be used to make the mRNA sequence, and the mRNA sequence is then translated into the amino acid sequence, so like the amino acid names. It's important to note that translation, the coding strand is read from 5' to 3'. So this is important when you're talking about directionality and when you're translating the sequence given. And I'll explain a little bit more with an example, that you're not always going to necessarily read something from left to right when you're translating something. Okay, the second thing is the template strand, also known as the non-coding strand. It's also referred to as the antisense strand. This is the sequence that is complementary to the RNA sequence that will be produced. Again, complementary meaning using Chargaff's base pairing rules, so think of it as like the opposite. The template strand is transcribed into mRNA, the coding strand is not. So a trick I like to think about is the template, the definition of template. So it's something that serves as a model for others to copy. So an example would be a professor gives you a template of an assignment or a project, but it's ultimately up to you to make it slightly different, make it unique. So here's a little meme that I thought was funny. Can I copy your homework? Yeah, just change it up a bit so it doesn't look obvious you copied. Here in this example, you have Ed Sheeran would be that kind of original, and then you have his look-alike, being that 2.0 version. Again, it's similar, but not quite the same. So the mRNA produced from the template strand is going to be the complementary or the opposite version of it, which I'll explain a little bit more here in these examples. Okay, so let's look at the first example. You have the template, you are given the template strand here at the top, and then you're asked to write the sequence of the mRNA. So the first thing that you're going to do, if you are given the template in order to make the coding strand, so this is, again, given the template, disregard that top, given the template, and you're now making the coding strand. Again, remember that the coding strand is the complementary version of it, so you're going to essentially write everything like the opposite or the complementary version. So you're thinking, what does the letter I'm looking at pair with, like base pairs? So remember that A pairs with T. So you're just going to go down the line and essentially look at what kind of goes together, what pairs together according to the base pairing rules. And then when you're looking at your primes, again, because you're doing the complementary version of it, it needs to be the opposite primes that you're looking at. So here there is a 5 prime, so then the coding strand would have a 3 prime. And then the same goes for the 3 prime. Here on the right, you're going to make sure that it is 5 prime. So once you've done that, now you have your coding strand. And now in order to make your mRNA, all you have to do is drop down your coding strand, copy it exactly, but remember to replace those T's with U's. So then, anywhere you see a T, replace it with a U. And again, your primes stay the exact same. Right, and then there is your mRNA. So again, if you're given your template, you will need to find, figure out what your coding strand is in order to make your mRNA. All right, let's move on to the next one. Same question, but a different strand here, except this time we are given the coding strand instead of the template. So the nice thing about this is when you're given the coding strand here, you actually don't have to write anything. You don't have to write the template strand if the question is asking you to write the mRNA. Now, if the question is asking to write both the template and the mRNA, then you will have to write both. But in the case of just asking strictly for the messenger RNA, you don't need to write anything for the template. So you don't necessarily need to write it in order to get the mRNA sequence. So again, all you're going to do for your mRNA is drop it down and then copy it exactly. And then again, remember to replace those T's with U's anywhere you see one. And then don't forget your end primes, your 3 primes and your 5 prime. All right, and then again, here is your final version of your mRNA. Right, and then here's another example. Again, same deal. You're given, again, this time your template instead of your coding strand. So definitely pause here now that you practiced a couple times and seen a couple examples. Pause this video now before I kind of walk you through the answer and check your work. Okay, so I'm going to go ahead. So if this is 3 prime, this would be 5 prime. And then again, complementary base pairing rules. So that would be your coding strand. And then from that point, you can drop down your sequence and make that mRNA. All right. And then again, that is your mRNA sequence. So then once you're done with that, you are finished with the problem. One thing I would like to note though, if you're not a big fan of writing the coding sequence, that is not the only option per se. If you'd like to do something different, there is the option to essentially skip the coding, like writing out the coding step and going straight from the template and going to the mRNA. So what I mean by this is instead of writing out the whole coding strand and then copying it again, switching out the T's for U's for your mRNA, if you think about the template strand in the sense of your mRNA is the complementary version of it or the opposite, you can go straight from the template and think to yourself, what is the complementary version? But remember, remember your base pairing rules. However, don't forget to replace your T's with U's. I know I sound like a broken record, but that is typically the thing that most people forget to do. So it's really, really important that you do it. So when I say this, if you get rid of the coding strand, pretend like I never wrote it in, and you just look at this template strand here, if you do the base pairing rules and you do the opposite, so opposite of 3 would be 5, and then you think to yourself, what is the opposite of T? So go A, and then here you have an A on your template strand, but remember it would typically pair with a T, but since this is the mRNA that you would be writing, it has to be base paired with a U. So U, A. So you can do it that way as well. Again, you can see that we got the exact same answer. Ooh, apologies, that's supposed to be a C. As you can see, we got the exact same answer as the one in red by doing that version of thinking, oh, what is the complementary version of it, and then just replacing it with U's. That's essentially what you're doing with the coding strand. You're just writing the step out. I typically encourage people to write the coding strand, especially I like to do it myself because that way you can kind of double check your work and make sure you didn't make a mistake, kind of like I just did. But it's also just a good way to show your work and think through the process. Okay, so again, here are the answers. If you wanted to stop and look at them, same ones I had before, but a little bit cleaner to look at. Okay, next I'm going to give you 2 more. It's the exact same strand, but again, I just want you to practice on your own. So pause the video here, practice, and make sure that you get the answers right. Okay, so in this example, if you're given the coding strand, all you have to do to make your template, to make your mRNA is drop that sequence down and copy it exactly, and switch out your T's with U's. Alrighty, and then once you've done that, the next thing, again, going to kind of do the opposite, that you are given the template strand instead, and you need to make the mRNA. So again, you can do one of 2 things. You can either write your coding strand, which I will show here in the example, just because that's what I like to do. Again, you don't have to write your coding sequence out if you feel confident enough that you don't need to, but it's always good practice to do, to practice and write out your coding strand. Alrighty, and then again, to make your mRNA, just drop this down right here. I need to put my 5' here on the end, but then just drop this down and then make your mRNA sequence. It's also a little bit easier if you kind of do it right underneath, but clearly I am writing a little too big to do that. All right, and then once you have done that, you have written your mRNA. I think, make sure I lined this up correctly. Oop, excuse me, accidentally misaligned this. So this should actually be AUU. Sorry about that. AUU. Okay. So once you've done that, you should be good to go. Oh, and I also messed up these primes. Apologies. Sorry, guys. See, this is why it's always good to double check your work, and that's why I always like to double check my coding and my mRNA strands. The one thing that I did say at the very beginning of this video is that the translation, that during translation, the coding strand is read in the 5 to 3 prime. So I'm going to show you a couple examples real quick that we did. So as you can see, the template strand, or the coding strand here, we wrote it as the 3 to 5, but technically, if you were to write this and translate it, you would actually have to start in this direction. You'd have to read basically from right to left, simply because it is always translated from 5' to 3'. However, here, your mRNA is also going in the 3 to 5, so again, you would have to read it from 5 to 3, reading from right to left. Down here, though, the mRNA strand is actually being read 5 to 3, reading from left to right, just because that's how we read it. But it is going in the correct direction, so you would actually be able to start translation right here at this 5, where in these, you would actually have to start at the opposite ends, so you'd start right here at that UUC, and you'd actually have to go backwards when you're thinking about it, which is a little bit trickier. You'd actually have to read it starting at the C, so you'd actually read it CUU. But just consider directionality when you're thinking about your strands. So in this case, it's reading from the 5' to 3' end, so again, you'd get to read it from left to right, which is nice, but it's not always going to be that case, because down here, as you can see, it's being read from 3 to 5, so again, you would have to read it going in this direction. So that's just something to keep in mind, to consider. It's important just to think about directionality, especially when we start getting into translation. But right now, nailing being able to code something, or being able to be given a template and being able to produce the coding and mRNA strand is good. Make sure you're able to solve it, both being given the template or the coding strand, but also think about it in the sense of you're given the mRNA strand and you're working backwards to create the coding or the template. And I know Tim's video has an example working backwards, which is really good for practice, but just make sure to consider those as well. So I hope this video helped, and I will see you in the next one.